listening. Just put it off to the side. Okay, so here we go. Ma'am, can you what? Yes. All right, so factoring. What does it mean when we say factor out a GCF? What is GCF? How does that even work? What does it mean to have the greatest common factor? What does that mean when I say that word, or you say that word? Greatest means the largest. Okay, so it's the biggest number that divides all of the terms. Okay, that's how we want to say that. I think that'll help us. So the greatest common factor, when we say that, it's just the biggest number that divides all of the terms. Okay, it's the biggest number that divides all of the terms. When we talk about the greatest common factor, we also need to think about the variable terms. We need to also think about the variable terms. Okay, so when we think about variable terms, I want you to look for the greatest common variable is the lowest power or exponent they share with the variable. So it's the lowest that they all share, meaning do they all have an x squared? Do some have x squared, some have x cubed, some have x to the fourth? Because if that's the case, then they all still have an x squared. It's just nestled in there. Okay, so that's what you're looking for. The lowest power or exponent that all of the variable terms have. And then you just write out the GCF. You take that greatest common factor and you write it out. You say what the GCF is, and then you divide every single term by that number. Okay? It's basically the opposite of distributing. We're undistributing, right? We're going to do the reverse of distributing. So when I look at my first example, you have to kind of ask yourself, what is a number that divides both 35 and 42? And I want you to know that if you don't know that off the top of your head, that's fine, because I gave you guys all times tables. A lot of you left them here. You guys remember these little green sheets? If you have it, get it out. If you don't have it, throw your hand up. Get it again. Chandler, do you have this? Yeah. So, I honestly, do you have this, Jacob? So I really thought that everybody knew how to use the times table to like multiply and to divide. You got it? And actually, I was working with some kids on Thursday, and they were like, I was like, well, let's pull out your times table and look at factors. And they're like, I have no idea what you mean. So I'm looking for 35 and 42. So I just want to show you how to use your times table. So I'm going to pull one up. Because if I say to use it and you don't understand the process, then I'm not doing you a favor. Times table 25. Here we go. So I'm just going to make this really big, and we're just going to look at this. So this is your guys' sheet, your 25 by 25. When I'm trying to figure out factors of a number, I'm looking for the number 35 and what? 42. I want them in the same row. They need to be in the same row or the same column. So 35 and 42. Well, let's see. 35 is in the 5 column, so 42 isn't in there. Say again. 7. Oh my gosh, they're both in the 7 column or in the 7 row. And that's the only place that they both appear. So that means that the largest or the greatest common factor or the largest number that divides both of those terms is what? 7. So I want you to use your times table to help you find those factors. So that means that my greatest common factor is 7. So now what do we do with that? Well, we're going to take that term and divide it from each. We're going to take each one of these numbers and divide it by 7. We're going to write the 7 outside of the parenthesis. So what is 35x divided by 7? 5x. And what is 42 divided by 7? Plus 6. So when I factor this by taking out the greatest common factor, I get 7 times 5x plus 6, which you guys would then distribute, right? Because that's what you're used to doing. You're used to distributing. We're just doing the reverse of that. So let's look at number 2. Look at your times table. What's on column or a row? What number divides 18, 72, and 54? And we want the largest number. 18, 72, and 54. So I'm going to go back to my times table. So 3, they're all in the 3s. 18, 72 is way down here in 54. I heard someone say 9. Here's 18, 54, and 72. Is there a bigger one? 18. Yeah, they're all divisible by 18. 18, 54, and 72. So that's what we want to take out. We want to take out an 18 from that. Use your times table. Make that like a tool for you that you can use. So my greatest common factor is 18. And that means that I'm dividing each one of these by 18. So I'm going to take 18 and put it on the outside. So if I take that first term, 18x squared, and divide it by 18, what am I taking? Like, what do I have left? Yeah, I just have the x squared left. 72 divided by 18 is what? Look at your times table. How many times does 18 times what gives you 72? 18 times what? 4. So when I divide these, I'm left with 4x. What is 54 divided by 18? Or 18 times what is 54? Yeah, and because it's negative, we're going to write -3. So this is what it looks like after you factor out a GCF of 18. And I will allow you to use your times tables on your test. Even though you get a calculator, I just still think that this is kind of a good visual for that, okay? Let's go to the next one. So let's see. 35x squared y cubed plus 45x cubed y squared. So let's figure out the number, the constant first. What's something that divides them both? 5. Yeah, we can take a 5 out of each of them. But now we have to look at the variable terms. Let's see. This has an x squared and this has an x cubed. So that means that this contains x cubed is the same thing as x squared times x, correct? So that means that we could take an x squared out of it. It contains an x squared. All right, now let's look at the y. I have a y cubed and a y squared. Well, what is y cubed? Y cubed is the same thing as y squared times y. Yeah, so I could definitely take out a y squared. Yeah, so that's the greatest common factor. So I'm going to put that out front, 5x squared, y squared. I'm going to rewrite my problem so I can kind of show the division underneath it. So when I divide by 5x squared, y squared, for both terms, divide by 5x squared, y squared. Let's see, 35 divided by 5 is 7. The x squareds cancel out. Think about your exponent rules. Y to the third divided by y squared leaves me with just y, yeah. 45 divided by 5 is 9. My y squareds cancel out. And what is x cubed divided by x squared? It's just x. If you are struggling with that, remember how you learned that rule. This is x cubed. This is x squared. Remember that these just cancel out and you're left with an x. Okay? So this is your final answer. What about the last one? 24, 36, and 54. 6. Yeah, good job. I only saw 3 at first. I looked at that twice and I had to figure it out. So 6. What's the variables that I can take out? What's my smallest m that everybody has? Say it again. Yeah, everything contains an m squared. So let's take out an m squared. What about the n? What's the smallest n power? N. So I have 6m squared n. And what's the smallest p power? P. Yeah, so that's my greatest common factor. So I'm going to divide every single term by 6m squared np. 6m squared np. 6m squared np. So 24 divided by 6 is 4. God bless you. M squared divided by m squared, well, those cancel out. N divided by n, those cancel out. P squared divided by p is what? This is p squared. That's p times p over p. What happens? So I just have one p left. Yes. Plus 36 divided by 6 is 6. The m squareds cancel out. What is n squared divided by n? N. And the p's cancel out. Just give me a second. I'll give it to you. I've got a filled out copy. What about the negative 54 divided by 6? Negative 9. What is that? Yeah, negative 9. And then m squared cancels out. What is n cubed divided by n? N squared. And what is p cubed divided by p? P squared. You have to put your GCF that you took out front. 6m squared np. Okay. So I'm going to freeze that for a second. And then we're making a video. So those of you that did not finish your test or you were not here, you're gonna start that. Okay. So Jacob, you're gonna go to the test room. I've got a task for you. Jose is not here. Caleb, you are also gonna go to the test room. I put all your stuff back together. I gave you a new green sheet. Set it down. We'll finish filling it out. Okay. TJ, you're just going to get started. So clear off your desk. Can someone feel like they can take 2 sets of notes? Do notes for TJ? Like, can you do your notes and TJ's notes?
Would TJ do notes for me?
I don't know. Ask him.
Would you ever do notes for me?
Do
I don't know if he wants notes.
you want Aiden to take your notes, or are you just going to watch the video later? Okay. Are you going to go, Caleb, Jacob? I got your stuff. We'll fill out your stuff later, okay? I need you to finish your test. So TJ, come and grab this. Clear up your desk. Grab this. You want your green form, no calculator. Green form, no calculator. Jack is not here. You didn't get a green form when I was walking around. Why didn't you hold your hand up and say you didn't have one? Go smack yourself. Dakota, still absent. Daniel, I think I gave you 17 tests. Okay. So we'll check that out. Chandler, you're not going yet. Finish your stuff. Sam, not here. Oh, look at that. Kara, clear up your desk for me. Polly, Elizabeth, And Danae. Guys, zip it. We still have people working on tests. So what? Okay. So let's keep moving. So now we're going to talk about factor by grouping. Is it going to bother you guys if I talk? What? Can you send them an email and I'll call? You did? Who is it? Who's your? Grab me a pass, Chandler, please. Hey, my dear, can I send Chandler down too for a few minutes, Chandler Allman? All right, I'm sending him with a pass. Thank you so much. All right, honey, bye-bye. Here you go, sir. Thank you. Okay. So if the noise bothers you, feel like we can get you a desk outside. I'm totally fine with that. Here we go. Factor by grouping. So we recognize that we need to factor by grouping because the problems have 4 terms. They have 4 terms. That's when we know that we need to factor by grouping. I'm unfreezing. They have 4 terms. So when we factor by grouping, we split the problem into 2 pairs and we put them in parentheses. And then we just take a GCF out of each pair. You take a GCF out of each pair. So when I look at my first example, I have x cubed plus x squared plus 2x plus 2. So I have 4 terms. So that means that I have to group them. I have to create 2 groupings. So you're just looking for a GCF for each grouping. So what is something that I can take out of my first? Out of the first one. Yep. X squared. And out of the second one, a 2. Okay, so let's do that. When I take an x squared out of the first term, what is x cubed divided by x squared? X. And what is x squared divided by x squared? 1. Plus, I'm taking a 2 out of the second one. 2x divided by 2 is x. And 2 divided by 2 is 1. You want that to repeat. You want to have, I call that the copycat. You have to have the stuff that's in the parenthesis be repeated. So that's your first term. That becomes your first binomial. X plus 1 multiplied by what you have left over. Well, what you have left over is you took out an x squared and a plus 2. Do you guys remember doing that in math 1 or kind of? Okay. Factor by grouping is my most favorite method to factor. Okay. So when I look at example 6, again, I'm going to group it into 2 parentheses. Make sure that the sign in front of the terms are included, right? So what is the GCF that I can take out of this first parenthesis? 2a squared. Yeah. What's the GCF that I can take out of the second parenthesis? 3. And you notice how both these terms are negative? So I want you to take out a negative 3. So let's look at what that's going to be. No, because the 15 doesn't have an a on it. Okay. Yeah, that's a good question. So I have 2a squared. Let's see. 4 divided by 2 is 2. A cubed divided by a squared is a. I don't know why it keeps doing that. Is a. What about 10? 10 divided by 2 is 5. A squared divided by a squared, those just cancel out, right? Plus, I'm taking out a negative 3. So instead of plus a negative 3, I'm just going to write minus 3 times, let's see, negative 6a divided by a negative 3.
Well, a negative divided by a negative is a positive. 3 will go into 6 2 times with the a. And negative 15 divided by negative 3 is positive 5. And that makes sense because we want to have this what? Yeah, you want to have that copycat, right? You have to have that. So if you don't, then that means you did something wrong. Okay. And a lot of times it's a change in the sign, meaning that you probably should have taken out a negative instead of a positive. Okay. So what do I have? Take out your first term, 2a plus 5. You take your copycat, that becomes the lead. And then what do? What you have left over, 2a squared plus, minus 3. My marker just stopped working. Sorry. Gosh darn it. Yes, it's going to be 2a squared minus 3. Give me a second. I have to bang it. So notice it says in the directions that when you're done, your answer should be the product of two binomials. And that's what we have, the product of two binomials. Okay. So I'm going to pause and I'm going to let you guys try these. I'm going to freeze the screen. And I want you to try 7 and 8. Actually, I'm going to do 7 with you just because. Okay, number 7. When I group those up, I'm going to take an x squared out of the first one. The second grouping, all I can see that I can take out is a 1. Do you guys see that? So let's see. I'm taking an x squared out of the first grouping. 2x cubed divided by x squared is just 2x. X squared divided by x squared is plus 1. When I take out a positive 1 from the next one, the next grouping, then I'm able to get my copycat, 2x plus 1. Remember that your copycat is what comes out first. That's going to be your leading binomial. So 2x plus 1 times what you have left over, x squared plus 1. You have to take something out. You have to take something out. And sometimes it is just going to be a 1. It is possible to just have a greatest common factor of 1. When I look at my next example, I can divide the first grouping by 5x cubed, and I'm going to divide the second grouping by a negative 1. By a negative 1. Because this leading coefficient right here, this is negative. So I'm going to divide by a negative. So let's see. 5x cubed, 5x to the fourth divided by 5x cubed is x. 5x cubed divided by 5x cubed, that's minus 1. Thank you, sir. And then I took out a negative 1. So negative 1 times, let's see, what's a negative x divided by a negative 1? A negative, it's a positive x. What's a positive 1 divided by a negative 1? It's a negative 1. Do I have my copycat? Yes. So that's going to be my leading binomial, x minus 1. Multiplied by, what do I have left? 5x cubed minus 1, I think, right? Did I do that one wrong? I think it should be 5x cubed. Yeah. Okay. We're almost done. So we've done factoring by taking out a greatest common factor. We've talked about factoring by grouping. And this last one is the zero product property, which says that when you have a factor, or when you take two binomials and you multiply them together, if they equal 0, remember that means either the first term equals 0 or the second term equals 0. So if x minus a equals 0, when I add a to both sides, x equals a. Or if x minus b equals 0, when I add b to both sides, x equals b. This should remind you of the factored form, right? If the factor is joined by a minus, that means that the root is positive. If the factor is joined by a minus sign, then the root is positive. We've actually worked with this already, right? When we did factored forms. So how do you do this? How do you solve an equation? Well, the steps. First, you bring all the terms to one side, put it in descending order. So that way you're setting the other side equal to 0. Okay. And then use the zero product property to solve. So let's look at number 9. Step number 1, I have to set it equal to 0, meaning I have to move everything to one side. So I'm going to subtract 3x first. So that gives me x squared minus 3x equals 0. So it says factor completely. We have to use one of the methods that we just learned, either factor by grouping or factor by GCF. Well, what do you see that you can take out of here? What can you divide both of these terms by? You can divide them by x. So you can rewrite this as x times the quantity. Let's see. X squared divided by x is x. And negative 3x divided by x is negative 3. So what does that mean? That means that this first term equals 0. Or your second term equals 0. Well, if x minus 3 equals 0, how do I solve that? I'm trying to get x all by itself. Add 3 to both sides. So x equals 3. So those are your two solutions. Example number 10. First thing I have to do is get everything to one side. So I'm going to add 5x to both sides. Move all of the terms to one side. So I have 4x squared plus 5x equals 0. What's the GCF? What can I take out of both of these? An x. That's it. Yeah, I'm going to divide by an x. So that leaves me with, let's see, 4x squared divided by x is 4x. And a positive 5x divided by x is just 5. So what does that mean? Well, that means that either x equals 0, that's my first term, or 4x plus 5 equals 0. Well, if 4x plus 5 equals 0, how do I figure out what x equals? Just subtract 5 from both sides and then divide by 4. Yeah, you're just doing a two-step equation. 4x equals negative 5. Divide by 4. X equals negative 5/4. So these are your solutions. Okay, so let's jump down at the bottom. It says solve and check. So number 19. Either x equals 0, that's one of my solutions, or x minus 8 equals 0. If x minus 8 equals 0, what do I do to both sides to solve for x? So that means x equals 8. These are the two solutions. How do I check that? Well, I can plug in 0. That would be 0 times negative 8. Because 0 minus 8 is negative 8 equals 0. Well, that's true. Or I can use the 8. Let x equal 8. 8 times 8 minus 8 equals 0. Let's see, what's 8 minus 8? What's 8 times 0? So it works for both numbers. Okay? That's what it means to check. So let's look at number 21. Either m minus 3 equals 0. That's my first term. Or m plus 5 equals 0. Do I have to keep doing that? What do we know? If m minus 3 equals 0, what is m? It's positive 3. If m plus 5 equals 0, what is m? -5. Are you guys okay with that? So I just added 3 to both sides. I'm just adding 3 to both sides. But we shouldn't have to show that. Or subtracting 5. We should be able to look at those one-step equations and solve them. What about example number 23? Is there a GCF? What is it? X. I have to take an X out. So when I do that, I have X times the quantity. Let's see, X squared divided by X is X. And -5X divided by X is -5. So either X equals 0 or X minus 5 equals 0. If X minus 5 equals 0, what is X? +5. Number 25. What do I have to do first? Move what? Yeah, I have to move that over to both sides, right? You have to get everything over to one side so you can set it equal to 0. So I have 3a squared minus 6a equals 0. What's the greatest common factor? 3a. So I'm going to divide by 3a. So when I take out a 3a, let's see, 3a squared divided by 3a is a. -6a divided by 3a is -2. So this means that either 3 times a equals 0 or a minus 2 equals 0. Well, if 3 times a equals 0, what is a? Yeah, you divide both sides by 3. 0 divided by 3 is still 0, right? Or you add 2 to both sides and you find out that a is what? +2. Okay, we're going to break it up. Who's going to do number 20 on the board? Okay. Haley, you do number 20 on the board. Who wants to do number 22 on the board? Aubrey, you got 22? No? Okay. Haley, you do 20. I'll do 22. And then we'll come back to it. I'm going to do 22. What does this mean? Well, yeah, it means that a minus 9 equals 0, which means a equals 9. Haley, just go on up to the board and do that, if you would, please and thank you. Or this says that 2a plus 1 equals 0. When I subtract a 1 from both sides, 2a equals -1. What do I do next? Divide both sides by 2, right? So a equals -1/2. Those are the two solutions. Charlie, you got number 24? Yes. So you end up with y plus 3 equals 0. So that means that y equals what? -3. Yeah, go do it up there. Holly, good job. Thank you. Okay, Aiden's put good job. Yes. So number 20, b equals 0 and b equals -12. Perfect. Thank you, ma'am. Number 24, Aiden is doing on the board. Who thinks they've got number 26? Dylan, you got it? Nope. Okay. Anybody else want to try it? Aiden, you got it? Laura, you got it? Perfect. So number 24, y equals 0 or y equals -3. I'll do the last one. What do I have to do first on 26? I have to move that 3. So I really have 2x squared minus 3x equals 0. Because remember, we have to set it equal to 0 to use the zero product property.
So do I have to like write down the subtract 3? Or can I just,
You can just move it in
I
your
don't know,
brain.
It just confuses me.
Yeah, just move it. Then what? GCF? Yeah, which is x. So when I take an x out, I have x times 2x minus 3 equals 0. So that means that either x equals 0, because that's my first one, my first product, or 2x minus 3 equals 0. So add 3 to both sides. 2x equals 3, divide by 2, which means x equals 3/2. Those are your two factors. Those are your solutions. So when we say that they're the solutions or the roots, I said earlier, these just tell you where the graph crosses the what? Yes. Good job, Aubrey. It's where it crosses the x-axis. Okay. All right, so I'm going to stop